Now, this is Shakil Ahmed. In this tutorial, we will discuss about simple linear regression. Simple linear regression is used when we are interested to see the effect of certain variable on certain other variable. Like, this example, we have related to heart disease, age of patient, blood pressure, cholesterol level, BMI, and sleeping hours. And we are interested whether uh, cholesterol level or whether sleeping hours or whether the cholesterol and or BMI is related to the blood pressure. We can use the simple regression analysis if we have one dependent variable and only one independent variable. So let's start with the simplest case. We take the BMI as independent variable and we see whether BMI is related to is affecting the blood pressure of an individual or not. Here is basically the dependent variable, and we see how the change in BMI is affecting the change in uh, blood pressure. Excel, we have data analysis option, data analysis toolpak. We can select the regression option. Sorry, can just select the regression and then click on OK. And we select the input range. That is our uh, that is a single variable with only age. No, sorry, with on select the blood dependent variable. That is the body mass index. So constant is equal to 0. With you want to run a model without constant, you can just take on this, and here we are keeping the constant in our model, and we just construct a 95% confidence interval for the coefficients. Like alpha and beta, we have the intercept and only one coefficient as we are working with simple linear regression. And then we have output sheet residuals and the plots. You don't need residual, I think you need residual plots and standardized residuals and line fit plot. And you can also check the normality of the residuals. Basically, these are all related to the assumptions of the simple linear regression. We assume that there is a linear relationship between in basically the dependent variable and independent variable, and zero mean and constant variance that is called homogeneity. Zero means no systematic bias or there is no autocorrelation, and so we check whether the error term distribution that is required for testing of hypothesis for the coefficient or that is called the slope coefficient. So let's check the result. So here are the results. We got three plots, and first of all we have the output that consists of multiple r square. That is the this is the correlation, and this is the r square. R square is very low, it means the model is performing worse. And this is the adjusted r square, that is negative. Adjusted r square means there uh, is only 0.0 almost 0.1% variation in the blood pressure is explained by the body mass index. So body mass index is not a good determinant. And you can see the coefficients. If you can see the coefficient is zero point 0.1 with the standard deviation, standard error of this, and the t value is small and the p value is very large. So there is no significant effect of body mass index on uh, share of an individual. And how would you interpret this result? We can say that with 1 unit increase in body mass index, there is only 0.1% increase in the blood pressure. That is not significant. So this is the interpretation. And this is overall significance of model. The model is also overall, there is no significance. And we have 95% confidence interval for beta, that consists of zero, that contains zero. Basically, this is negative and this is positive. It means the uh, confidence interval contains the true hypothesized value, that is zero. So it means there is no significant difference between the or there is no significant effect of the mass index on blood pressure of an individual. And visual plot, this is showing just a random pattern, and we can see that heteroscedasty, there is a little heteroscedasty, but there is not the errors are independent. There is a not relationship between x and y. This is the fitted line, and these are the observed values of y versus different values of x. And this is a normal probability plot. This is not, again, not showing a good normal behavior error term. So that's all about the simple linear regression. Thank you.